Welcome back to GyanDarpan, where we demystify programming concepts and make them accessible to everyone. Today, we're diving into the world of design patterns, specifically the factory design pattern. Understanding this pattern can significantly improve how you design and manage your code. So, let's get started. Let's understand what is the factory design pattern. The factory design pattern defines an interface for creating an object but allows subclasses to determine which class to instantiate. Essentially, it enables a class to delegate the instantiation process to its subclasses. Imagine managing a factory that produces various types of products. Instead of having one complex process trying to handle all products, it's more efficient to have dedicated production lines for each product type. Similarly, in software development, the factory design pattern facilitates object creation by delegating it to specialized factories. This approach enhances modularity, flexibility, and extensibility in your code. It aims to make a system independent of the specifics of how its objects are created, composed, and represented. By utilizing this pattern, a class offloads the object creation responsibility to a distinct factory class, thereby improving modularity and encapsulation. This results in more maintainable code and adheres to the principle of loose coupling. The factory design pattern is particularly valuable when managing and centralizing the creation of objects is necessary. It encapsulates the instantiation logic of objects, which might otherwise lead to redundant code. By promoting loose coupling, it reduces the dependency of client classes on concrete classes, enabling the client code to request objects from a factory instead of creating them directly. Let's break it down into its core components. At the heart of the factory design pattern are four key elements. Product. This defines the interface for objects that the factory method creates. It specifies the standard structure and behavior that all concrete product objects must adhere to. Concrete product. These are the specific classes that implement the product interface or extend the product class. Each concrete product corresponds to a particular type of product that the factory can produce. Creator. This abstract class declares the factory method, which returns an object of the product type. The creator may also provide a default implementation of the factory method, which produces a default concrete product object. Concrete creator. This class implements or overrides the factory method to return an instance of a concrete product. It is responsible for creating specific product objects. Let's put theory into practice with a Java example. Imagine a recruitment agency, thriving but struggling. With the diverse roles of software engineers, designers, and sales executives, managing recruitment became a puzzle. Each type of job requires a different recruitment process. Software engineering candidates need to be evaluated on their coding skills and technical knowledge. Design candidates should showcase their portfolio and undergo a creativity assessment. Sales positions require an evaluation of communication skills and a personality test. This is where our factory design pattern shines, offering a blueprint for our agency to craft tailored recruitment processes effortlessly. Like magic, the agency now uses a simple request to the recruitment factory, which conjures up the precise recruitment process needed for each role. Let's deepen our understanding by examining a Java coding example. Create a new package named recruitment.process, which will contain product and concrete product components for the factory design pattern. Next, create an interface named recruitment process. This interface will serve as a blueprint for the recruitment operations, outlining the necessary methods that any concrete recruitment process must implement. Next, within the recruitment process interface, define two methods. First, implement the assess skills method to evaluate the candidate's professional skills and expertise. Following that, define the conduct interview method, which will be responsible for carrying out the interview process to further assess the candidate's fit for the position and the organization. Next, create a new package named impl within the recruitment.process package. This impl package should contain different types of implementations for the recruitment process interface, providing concrete classes that specify how the recruitment process is conducted, including the methods assess skills and conduct interview. Next, create a new class named Software Engineering Recruitment within the impl package. This class should implement the recruitment process interface and provide specific implementations for the methods assess skills and conduct interview, tailored to the recruitment of software engineering positions. Next, within the IMPL package, create another class named Design Recruitment. This class should also implement the recruitment process interface, providing implementations for the assess skills and conduct interview methods specifically tailored to the recruitment process for design positions. Next, create a class named Sales Recruitment within the IMPL package. This class should implement the recruitment process interface, offering specific implementations for the assess skills and conduct interview methods, focusing on the recruitment requirements and nuances of sales positions. Next, create a new package named recruitment.factory within the com.gan.darpun package. This package will contain the creator component of the factory design pattern. Next, within the recruitment.factory package, create an interface named recruitment agency. This interface will act as the creator in the factory design pattern, defining the methods responsible for creating and returning instances of the recruitment process type, aligning with different recruitment needs such as software engineering, design, and sales. Next, create a new package named IMPL within the recruitment.factory package. This IMPL package will contain the concrete implementations of the recruitment agency interface. Next, within the IMPL package of recruitment.factory, create a class named agency. This class should implement the recruitment agency interface, providing concrete implementations of the methods defined in the interface. The agency class will serve as a factory for creating instances of different types of recruitment processes like software engineering recruitment, design recruitment, and sales recruitment. To test the implementation, should open or create a main class file. In this main class, we will write code to demonstrate how the factory design pattern works in the context of our recruitment system. Create an object of recruitment agency by instantiating the agency class. Now, let's initiate the software engineering recruitment process. We will call the create recruitment method on the recruitment agency object and pass software_engineering as the input. Next, let's proceed to assess candidate skills and conduct interviews for the recruitment process. We call the assess skills method to evaluate the skills of the candidates applying for positions, and conduct interview method. Next, run the main class. Here, you will see the output from the software engineering recruitment class in the console. If you want to conduct a design interview without using the factory design pattern, you would need to declare a design recruitment object and then call its assess skills and conduct interview methods explicitly. However, if you're using the factory design pattern, you won't need to change the code significantly. You would pass the type of recruitment process that needs to be instantiated in the recruitment agency, and it will create the required object of recruitment process based on the type specified. For example, if you have different types of recruitment processes like software engineering recruitment, design recruitment, etc., you can pass the type, e.g., design, to the recruitment agency, and it will create the appropriate object for conducting the design interview without requiring you to change the code manually. This flexibility and abstraction are key benefits of using the factory design pattern in this scenario. Next, pass design as input to the create requirement process method. This will return the design requirement object and run the main class. This time, we will observe in the console that we receive output from the design requirement class. Why is the factory design pattern a game changer in the programming world? Encapsulation of creation logic. It's like having a secret recipe. The factory pattern keeps the creation logic under wraps, separating how things are made from what is being made. Decoupling. Imagine changing one part of your code without affecting the rest. That's decoupling. This pattern keeps your system components independent, enhancing flexibility. Adherence to single responsibility and open/closed principles. The factory pattern is a stickler for rules, following key design principles by separating concerns and allowing easy expansion without modifying existing code. Ease of expansion. Need to add new features? The factory pattern allows for easy additions without entangling them with existing code. But where does this pattern really shine? Let's look at some practical use cases. Complex object creation. In software land, creating objects can get tricky. The factory pattern simplifies this, managing the heavy lifting behind the scenes. Framework integration. For the framework architects among us, this pattern helps in crafting flexible systems that hide the complex logic, providing a clean interface to users. Configurable systems. When your system needs to adapt like a chameleon, changing its behavior based on the environment, the factory pattern can dynamically create the right objects for the right situation. Resource management. Managing resources efficiently is crucial, whether it's connections, sessions, or threads. The factory pattern can act as a resource handler, optimizing usage and allocation. Product families. Creating a suite of related products? The factory pattern helps in manufacturing these related objects seamlessly, maintaining consistency across the product line. And there you have it. The factory design pattern in a nutshell. It's a powerful tool in your design pattern arsenal, helping you write cleaner, more maintainable code. If you enjoyed this explanation and want to see more design patterns come to life, hit that like button, subscribe, and ring the bell for notifications. Happy coding, and I'll see you in the next video.